Hello students, good morning. How are you all? I hope all are doing great. Once again, very warm welcome for today's session. We'll be discussing about the mole concept topic and numericals related to mole concept. In last class, I have given few numericals. I hope you are able to solve the numericals. I hope you are able to get the formulas and able to get the answers too. Yes, good morning. Good morning, Reda. Okay, good morning. Good morning. Good morning. Good morning, Ravi. Good morning, Kumar. Bhavikata. Okay. Vishnu, good morning. Yes, namaste. Good morning. Abhiram, good morning. I'm very, very happy to see you guys into this class. Okay, shall we start the class? Yes, today is the day of results for your seniors. So today IPE first year and second year results. So your senior students are excited to know their results. Okay, fine. Good morning, one and all. I hope it is time to start the class, right? So students, I thought in yesterday's class, to recollect the atomic masses. Okay, your bro got 446. Good, good, good. Oh, nice, nice. He is in Sri Chaitanya. Good. Here, many people have got 450 and above marks also. People are getting here. Good, good. So, students, please stop chatting. Oh, 530 out of 530. Yes, my sister got 530 out of 530. Chandra. Okay. Superb. Awesome. Excellent results. Okay. Good. Students, without further delay, please stop the chart and focus on the class and look at here and try to note down the formulae which I am going to write here. Okay. Good. So I wanted to write the atomic masses of some important elements also. Here I am just trying to represent the element. Some students are asking me to mention the atomic masses of elements. So that is the reason why I am writing the atomic masses of some important elements. Here I am writing atomic mass. As we know, atomic mass is mass of an atom which is expressed in AMU, or you can also refer it as U. And I will also mention here gram atomic mass. Gram atomic mass. Quickly give your responses. If I am taking, let's say, hydrogen, atomic mass is 1. Quickly. And its gram atomic mass we are expressing in grams. Okay. Next, helium, its atomic mass is 4. Unified mass or AMU, its gram atomic mass is 4. Lithium, 7 here and 7. So the main difference between atomic mass and gram atomic mass is, as we have discussed already, atomic mass is representing mass of a single atom, whereas the gram atomic mass represents the mass of 1 mole of atoms. Fine. And then beryllium, it is around 9 and it is in grams. Boron, as we know, 11 and over here 11. Carbon atomic mass is 12 gram, atomic mass is 12 grams, and nitrogen 14, 14, and oxygen 16 and 16. There is a shortcut method also, or short trick method also, to remember the atomic masses. Here I am writing the other, and after oxygen you have fluorine. Its atomic mass is 19 AMU and its gram atomic mass is 19 grams. Neon we don't use much. Anyway, we will be writing sodium. Its atomic mass is 23 AMU. Its gram atomic mass is 23 grams. Magnesium, its atomic mass is 24 AMU and gram atomic mass is 24 grams, just to refer. Okay, and then aluminum is 27 AMU is its atomic mass, but 27 grams is its gram atomic mass. Silicon 28, 28. Phosphorus 31, 31. Sulfur 32, 32. And chlorine is most famous element. I think most of you guys knew about the atomic mass of chlorine. It is 35.5 grams. And then argon we don't use much anyway. I am writing its atomic mass and gram atomic mass. Potassium is somewhere around 39 and gram atomic mass also I have mentioned. Calcium, it is 40 and gram atomic mass is 40 grams. Here we can write AMU or U. Very nice, superb. Many of you guys are able to recollect the atomic masses of the elements which I have mentioned, right from atomic number 1 up to atomic number 20. The elements after atomic number 20, if they mention the elements atomic number beyond 20, they will definitely mention their mass. Okay, right. So anyway, I am just trying to represent the atomic masses of at least few elements. So chromium, it is around 52, 52. These are not much important, not much important. Manganese is around 55 and iron is around 56 and copper is 63.5. This is its atomic mass, and the gram atomic mass of these elements is expressed in grams. It is in AMU. Atomic mass expressed in AMU. Gram atomic mass usually expressed in grams. This is 52 grams, 55 grams, 56 grams and 63.5 grams. Apart from that, silver, I think you know very well, 108. 108. It is actually government ambulance. Okay. So its gram atomic mass is 108 grams itself. If at all bromine is given, its atomic mass is 80 AMU and its gram atomic mass is 80 grams. If iodine is given, its atomic mass is 127 AMU, its gram atomic mass is 127 grams. Okay. Yeah. Okay. My dear students, if you are able to recollect the atomic masses of the elements which I have mentioned, you can, I can say, like safely study or with comfortable. I mean, beyond the atomic masses of any other elements are not required to remember. If any element is mentioned, they will definitely mention their atomic masses. For the 2 years course of our journey, if you are able to remember the atomic masses of the elements which I have mentioned, it is more than sufficient. More than sufficient for any kind of topic, for any kind of calculations. Okay. So please try to remember the atomic masses of the elements which I have mentioned. Apart from this, today I thought to recollect all the formulas before going to work some other examples related to mole concept. Right? So dear students, let me give heading over here some important formulae, just recollection related to moles. Then followed by we will try to work on some numericals. I hope you are following. Shall we? Okay, you guys have to mention or try to write these formulas. Okay, the first and foremost formula which I have mentioned is calculation of moles. Moles can be calculated in three ways. Formula number one, which is given mass by gram atomic mass. The second formula is given number of particles upon Avogadro's number. The third formula is in terms of volume at STP, volume of gas at STP upon 22.4 liters. Here volume at STP is given in liters. If you take the given volume in liters, denominator must be 22.4. This is the first formula which I have given. Once you are able to find out the number of moles, then we can proceed smoothly. Number of molecules. Students, it's better if you can note down these formulas. Number of molecules is equals to n times that of Avogadro's number. Third formula, number of atoms. So hereafter, anything which they have given or which they are asking, it is interrelated with the number of molecules. For example, if they are asking number of atoms, just multiply the number of molecules with atomicity of the given molecule. Atomicity. This is most important formula based on which questions were given many a times. Next, number of electrons present in a given sample, that is equals to again the same story, n into Na. Here if they are asking atoms, we need to multiply with its atomicity. If they are asking number of electrons, it should be multiplied with the number of electrons present per unit of given sample in single unit of the sample. Right. Next, formula number 5. I hope you are noting all the formulas. Formula number 5. Dear students, I would encourage you guys, if you are able to recollect all these formulas, you can even proceed working questions in your first year chapter, some basic concepts in chemistry. There you will study about mole concept. If you are thorough with all the formulas which I am going to mention here, you can be able to work the almost all kind of questions in your first year. Okay, please note down the formulas and try to work as many as questions related to these formulas. Number 5, total number of protons. If someone is asking total number of protons is equals to again same story, n into Na into number of protons. All the formulas are related to the same story. Protons present per single unit, present in a single unit. If someone is asking to find out the total number of nucleons, total number of nucleons is equals to n into Na into number of protons plus neutrons present in a single unit. Right? With this, I wanted to close. If they're asking about total number of electrons, already I have given. Okay. If they're asking total number of electrons plus protons plus neutrons, the same story. N into Na, N multiplied with Na multiplied with electrons number plus protons number plus neutrons number present in a single unit of given sample. Right, few more points I am trying to add up over here. Students, this is very important point. Nowadays, number of moles are represented with number of gram atoms. If somewhere around, if you find number of gram atoms, it is used to refer number of moles itself. If somewhere around, if it was mentioned with second one, this is for elements I refer. Okay, number of gram molecules, it is for molecules. You can also refer it as number of gram ions, right? So number of moles are actually using nowadays in terms of number of gram atoms or number of gram molecules or number of gram ions. Number of gram atoms itself is number of moles. Number of gram molecules is also equivalent to number of moles and number of gram ions. Okay, gram ions is used to collectively represent number of moles. Okay, if you take, let's say, 1 mole, assume 1 mole of atoms is collectively referred as 1 gram atoms. 1 mole is also collectively used to represent 1 gram molecule. 1 mole of ions is used to collectively represent 1 mole of gram ions. Is it okay? Yeah, sure. I'll write. Okay. So please try to have an idea about all these important points and formulas. Okay. So all the formulas are very important. Here I have given a new term, that is gram atom. Gram atom is collectively representing number of moles. Even the gram molecule is collectively representing number of moles itself. If I refer gram ions, it is used for representing number of moles. Is this point clear? Could you move aside for one? Yes, sure. Yeah. Just note down. Good. So good part is many people are noting the formulas. I'm very happy. Please note down all the formulas and important points which will be really useful for your future classes. Okay, with this, I'll try to close and give for compounds. Yeah, we'll solve some questions. We'll solve some questions so that you can use all the formulas once again. As I mentioned already, students, mole concept topic is very important in your course of first year and second year. Okay, mole concept will be used in different chapters. Let's say, for example, in first year, some basic concepts in chemistry, actually the mole concept topic was introduced. Okay, in second year chemistry also, we will use the same mole concept related questions in solutions and colligative properties chapter, and we will also use the same topic in electrochemistry also. There is one more chapter in first year, redox reactions. So almost more than 3 chapters, around 4 chapters, the mole concept is interlinked. Yeah, we will calculate. Good. Right. So we are going to work on the questions. Have you noted all the points? Students, have you noted the points? Good. Yeah, students, I my request is, if the video is useful for you and it is helpful for you, we are requesting you to share the link for your friends so that those people also can be benefited. Okay, right. So we are going to work few more examples for today's class. Question number one. Question number one. 12 grams of carbon 12 isotope. Okay, I have given 12 grams of carbon 12 isotope. Given sample 12 grams of carbon 12 isotope. What you need to find out from this 12 gram sample of carbon 12 isotope? Find the total number of atoms. Total number of atoms. Carbon atoms, number one. Carbon atoms, number 1 point. Number 2, total number of electrons in the above sample. Total number of electrons you need to find out. And the third point is total number of protons I need. Fourth one, total number of neutrons. Fifth point, total number of electrons plus protons plus neutrons. Shall we start working on this question? Very simple question and basic level question. You are given 12 grams of sample. You guys have to find out the total number of carbons present in 12 grams of C12 isotope and total number of electrons you need to find out, total number of protons you need to find out, total number of neutrons you need to find out, and then finally total number of electrons plus protons plus neutrons. Sir, since content is state and NCERT books is same, so which set of books? My student, I think, Karthik, good question. It's better to have the set of NCERT books. My advice to you is not the latest publication. If you can take the NCERT set or books in old publication, that is around 2020 or 2021, okay, or else before COVID, those books are actually very good. So the content is very good, and they have deleted some of the topics in recent years anyway. The new publication, instead of having the new publication, it's better to have the old publication. If you have already taken the new publication, no worries. And my another advice is, if you are having even state board book also, it would be good, so that you can prepare for even state board IP exams. In the book, after giving the chapter, after completion of chapter, you will find questions in NCERT and even in state board also. And state board books, mainly it is descriptive way of questions are given, but in NCERT, after completion of chapter, they'll mention synopsis, and various questions will also be there. You need to solve the questions which were given after completion of each and every chapter. Okay. Yeah, after coming here, I think don't worry about the purchasing of books. After reaching here, everything will be directed. Don't worry. Please focus on the class. Try to calculate. Yeah, don't worry. All the books will be provided over here only. All the books will be provided here. Okay. Right. So then try to work on this question. Try to work on this question quickly. Try to work on this question quickly. Fine. Okay, you are given 12 grams of sample. Just try to find out number of moles quickly. How many of you are getting answers? Given mass is 12 and gram atomic mass of carbon is also 12. We are having 1 mole. Okay. 1 mole means how many atoms are present? Na atoms are present. How many total number of electrons are present? How many total number of electrons are present? Since atomic number of carbon is 6. So here each carbon contains 6 electrons. We have Na atoms. Therefore, we will be having 6 Na electrons. How many protons will be present? Since this is a neutral atom, 6 Na protons we have. How many neutrons are present? Yes, as we know, mass number of carbon was given as 12. Number of neutrons is equals to 12 minus 6. Each carbon has 6 neutrons. Therefore, 6 Na neutrons we have. Altogether, if they are asking us to find out total number of electrons, protons plus neutrons, Na times that of 6 plus 6 plus 6. Altogether, we are having 18 Na particles. Fine. Yeah, it's better. I suggested, okay. If you want the clear-cut explanation, everything, and I mean paper quality, everything, you need to go for the old version. It's better to have new version, okay? Because the new publication books are not including the deleted chapters. Okay, if you are having a new publication, that is specifically for the NEET examination pattern only. Okay, then the old books contain some chapters which were deleted, which may not be there for the NEET examination. Okay. Okay, don't worry, the addition and everything will be distributed here only. No need to worry about the NCERT books and state board books. Okay, that's it. Okay, right. So focus on the class. Next question. Next question is question number 2. You were given 2 moles of sulfuric acid. 2 moles of sulfuric acid. 2 moles of sulfuric acid contains. Okay. My question to you is, I have given the sample of 2 moles of sulfuric acid, and you need to find out total moles of hydrogen atoms. Total moles of hydrogen atoms. Question number 1b. Total moles of sulfur atoms. C. Total number of gram atoms. I am including the term which I have given. Gram atoms of oxygen. Next point. Total number of gram molecules of oxygen, O2, dioxygen. Okay, fine, that's it. So try to work on. And one more, and the last one is total number of gram molecules of H2. Na is actually Avogadro's number. Na is Avogadro's number. I have given the symbol for Avogadro's number in the last class itself. Okay, in previous classes we have used Avogadro's number many a times. Try to work on this question also. Sridevi, it's okay. Okay, I hope you are working on the next question. 2 moles of H2SO4 is given. You guys have to find out total moles of hydrogen atoms. Total moles of hydrogen atoms, underline atoms. Total moles of sulfur atoms. Then I have mentioned the term number of gram atoms. Gram atoms itself is also referring moles. Again, I have represented the term gram molecules. Gram molecules also is referring for moles. Again, I have mentioned gram molecules. Gram molecules is also referring the moles, but in terms of molecules. Okay, right? So here, total moles of hydrogen atoms. You are given how many moles of H2SO4? Here I have given H2SO4, which contains 2 moles. 2 moles of H2SO4 is given. Okay, if I am taking, let's say, only 1 mole of H2SO4, if you can decode 1 mole of H2SO4, it contains, tell me, it contains, quickly tell me students. I am writing some statements. How many of these statements are correct? Yes, you have to mention. Here, 1 mole of H2SO4 contains 2 gram atoms, 2 gram atoms of H, right? Next, 1 gram molecule of H2. C, 1 gram atom, 1 gram atom of sulfur atoms, right? And D, 4 gram atoms of 4 gram atoms of oxygen. And we can also write in the same way 2 gram molecules of O2. 2 gram molecules of O2. Is this point clear? Is this point clear? Is this point clear? Let us look at H2SO4 of 1 mole sample. 1 mole sample of H2SO4 contains, look at carefully, if you are referring it as a molecule, 1 molecule we have, and 1 mole of H2SO4 contain 1 gram molecule of H2. It is true. Next, if you are converting into atoms, 1 molecule of H2 contains 2 atoms. Therefore, 1 mole of this sample contains 2 gram atoms of H. Correct statement. And 1 gram atom of sulfur atom, since 1 mole of H2SO4 is given. 4 gram atoms of oxygen, since each molecule contains 4 atoms, I have 1 mole of H2SO4. Altogether, 4 gram atoms of oxygen we have. And at the end, if you are converting the atoms into molecule, 4 atoms of oxygen is converted into 2 moles. Therefore, 2 gram molecules of O2 is present. Okay. Next, coming to 2 moles of H2SO4. 2 moles of H2SO4 contains. Quickly tell me answer. You have to multiply all these statements with 2. That's it. So write the answer. Total moles of hydrogen atoms. Total moles of hydrogen atoms. Total moles of hydrogen atoms. Fifth one, 2 gram molecules I mentioned. Okay, each H2SO4 contains 4 oxygen atoms. 4 oxygen atoms can be written into 2 molecules of O2. So each molecule of H2SO4 contains 2 molecules of O2. Then 1 mole of H2SO4 contains Na times that of 2. So 2 Na. 2 gram molecules means 2 Na. Fine. Now 2 moles of H2SO4 is given for you. 2 moles of H2SO4 contains in total 4 Na hydrogen atoms. Am I right? Since 1 mole of H2SO4 contains 2 Na atoms. Next, second point, B, total moles of sulfur atom. Since 1 mole of H2SO4 contains only 1 gram atom of sulfur, now 2 moles of H2SO4 will be containing 2 Na sulfur atoms. Correct? Next, total number of gram atoms. 1 mole of H2SO4 contains 4 gram atoms of oxygen. Now, how many gram atoms of oxygen will be containing in 2 moles of sulfuric acid? Altogether, we will be having 8 Na oxygen atoms. I hope you are following. Next, total number of gram molecules. If you take 1 mole of H2SO4, we have 2 gram molecules of O2. Then 2 moles of H2SO4 will be containing how many gram molecules of O2? How many gram molecules of O2? 4 Na molecules of O2. Correct? Next, total number of gram molecules of H2. 1 mole of H2SO4 contains 1 gram molecule of H2. Right? 1 gram molecule of H2. Then 2 moles of H2SO4 will be containing 2 NaH2 molecules. Fine. Okay. Very good question. This is somewhat tricky question, and such kind of questions are very important for our NEET exam. I hope all the points are clear to each and every one. Shall we recollect all the points once again? Before working on 2 moles of H2SO4 sample, please try to work on 1 mole of H2SO4 sample. First, try to decode 1 mole sample of H2SO4. We have 1 mole sample of H2SO4 is having total 2 gram atoms of sulfur. Because each molecule of H2SO4 contains 2 hydrogen atom, we have 1 mole sample of H2SO4. So 1 mole sample of H2 will be containing 2 gram atoms of hydrogen. Next, 1 gram molecule. Atoms, if you are converting into molecule, so 2 atoms is collectively referred as 1 molecule. Fine. Therefore, 1 gram molecule of H2, 1 gram atom of sulfur. This everyone can write the answer. If you talk about oxygen, in each molecule of sulfuric acid, we have 4 atoms. 1 mole of H2SO4 we are referring, hence 4 gram atoms of oxygen we have. 4 oxygen atoms can be converted into 2 molecules. Each H2SO4 molecule contains 2 O2 molecules. Now we have given 1 mole H2SO4. Therefore, 1 mole H2SO4 will be containing 2 gram molecules. We are comparing the same analogy with 2 moles of H2SO4. Now 2 moles of H2SO4 was given for us. It contains total moles of hydrogen atoms as 4 Na. Since 1 mole H2SO4 sample contains 2 Na hydrogen atoms. Now we need to just multiply with 2. Fine? Okay. Are you getting the answer, Chandrave? Okay. Chandra, I can call you as Chandra. Okay. Good. Okay. Shall we move on to the next question? Next question. Okay. Next question. So students, this question is very important question, very useful point. Question number, I guess, 3. Find the total charge on 1 mole of electrons. You need to find out the total charge which is present on 1 mole of electrons. You are given with charge on an electron, charge on electron, or electron charge, let it be. Okay, charge of electron, charge of electron. Yes, you will be knowing about the value also. Tell me, can anyone tell me what is charge on electron? What is the charge which is corresponding to only single electron? So as you know very well, 1.602 into 10 raised to the power minus 19 coulombs. Okay, just mention it as C. Okay, coulombs. SI unit of charge is C. CGS unit of charge, I think you know very well, ESU. Okay, you need to find out the charge on 1 mole of electron. You are given with very good. WAU132. Super, very nice answer. I think it is very easy question too. Okay, you are given with a charge on a single electron. You need to find out the charge on 1 mole of electron. As we know already, 1 mole means Na. Okay, the value also you will be knowing 10 raised to the power 23. Okay, and charge on each electron charge. Each electron charge is 1.602 multiplied with 10 raised to the power minus 19 coulombs. Now find out the charge on 1 mole of electrons. Just you need to simply multiply the charge on each electron with Avogadro's number. 6.022 into 10 raised to the power minus 19 coulombs. If you simplify, approximately you will get 96,500 coulombs. 96,500 coulombs is collectively called as 1 Faraday. 1 Faraday. So here 1 Faraday means charge on 1 mole of electrons. Charge on 1 mole of electrons. Is this point clear? Very important point. Charge on 1 mole of electrons is called as 1 Faraday. 1 Faraday value is 96,500 coulombs. Okay. So this is very useful when you are dealing in electrochemistry. Charge on each electron is 1.60 into 10 power minus 19. Charge on proton is, I think, just charge. Sign will change. For an electron, there is negative charge, and for proton, it would be positive charge. Charge on neutron. Neutron is actually chargeless, a neutral particle, zero charge. Electron charge is 1.602 into 10 raised to the power minus 19 with negative sign. Proton charge is positive 1.60 into 10 power minus 19 and neutron charge is 0. Okay. Fine. Okay. With this, students, we wanted to close the mole concept actually. I have given the formula which is related to mole concept, and from the, I think, beginning of the mole concept, we have dealt with different definitions, okay, such as atomic mass, molecular mass, and various definitions we have discussed, and various terms also we used, and I have given some important formulae in calculation of moles. Please continue to work on mole concept since this topic is very important. I think I have given few important numericals also related to mole concept. With this, we will stop the mole concept and we will be moving on, switching on to the next topic. Okay, so I think this is for today's class. I hope you enjoyed the class. I think you are following the class, you are learning something, and you are able to work numericals. You are able to connect the concepts from one into the another concept. Okay, if you feel this video is useful for you, please like and share and subscribe the channel. So that's all for today's class. Thank you so much.